All right, picking back up where we left off. The question was, if I change the size of the figure, will the angles change? Now, I said that if we keep this the same, we keep the shape the same. Now, if I change this, then the shape will change because this will have to go out a little bit further, and then this will have to raise up a little bit to accompany that. And so what will end up happening is if you change the angle, you change the shape, and we don't want that. So, nope. Remember, the sum of all three angles in a triangle must add to 180. If the size of the angles were increased, the sum would exceed 180. And so we would end up having to change what these all were, which means that we're going to change what our shape is. We can verify the fact by placing the smaller triangle inside the larger triangle. The 40-degree angles are congruent. The 70-degree angles are congruent. So what ends up happening, if you can see this 70-degree angle, it is congruent, as well as the 40. And finally, the last 70-degree angle is congruent. Once again, by putting a shape within another shape, we have a similar figure of triangles. Here is another problem that if you would like, you can work on it on your own. I'll give you a little bit of a pause, and then we'll continue with this lesson. Now, this looks messy because we're having to translate the two triangles. So now that we've broken them apart, we notice that we have 30 to 6, 40 to 8, and 50 to question. Now, I know right off the bat, if I want to go from 6 to 30, I would have to multiply by 5, or I would have to divide by 5. So therefore, the common factor of these triangles is 5. So the length of the missing side is 10. Similarity is used to answer real-life questions. Suppose you wanted to find the height of this tree. Well, in order to find the height of the tree, what you would do is, yeah, that's right. You'd have to have a tape measure, and you're too short to reach the top of the tree because you're not as tall as Mr. Skinner, right? Haha, funny, right? Now, you can measure the length of the tree shadow, which is 10 feet, and you can measure your shadow, which is 2 feet, but that still doesn't quite give you enough information. So, puzzled, what do? Well, we can find the height. So if Mr. Skinner's 6 foot and his shadow's 2 feet, we can use that information to find the height of the tree when we know that the distance of the shadow is 10. So I'll pause. Yeah, what exactly? So why is all the way here? And now we can continue with this. Yep, the tree must be 30 feet tall. Boy, that is a really tall tree, quite taller than Mr. Skinner. Now, similar figures work just like equivalent fractions. So if you haven't quite picked up on it yet, all we're doing is an equivalent fraction. The division by 6, and then another side has to be a division of 6. Okay, so similar figures are two figures that are the same shape, but the sides are proportional. So, practice time. Now, I will create one more practice time video for you, and this is where you are going to show your work and show that you have gotten this lesson and you've mastered it. So, on my next video, which will be part 3, I will go through the practice time questions for you, and you will create the answer, or you will get the answer for those answers and bring it to me on the 28th. All right. I'll see y'all in my next video.